Okay, patrons, welcome to the first exclusive video here on Patreon from the Blanco Lirio channel as we work together through the vagaries of the YouTube demonetization scandal, for lack of a better word, and get you the kind of quality aviation detailed reporting that you've become accustomed to on this channel. In addition to exclusive technical detailed information like this, I'd like to open up this format to some behind the scenes videos here at Blanco Lirio, and also as we generate more interest among experts within the industry and add them into the fold here on Patreon, open this up into live question and answer periods where we can really dive into technical issues that we're talking about and have you, the viewers, help me move ahead with this channel and become a board member, so to speak, and figure out which way do we want this channel to go together and what kind of stories do we want to talk about. Now on to the story about the cracks in the pickle forks in the 737 NG series of aircraft. I introduced this topic in the video below on the free side of YouTube. Let's just jump right into it. This story was broke 4 days ago by Charlie Harger of Seattle, Washington. He works for KOMO News Radio, and here on Twitter he announced it. And he's got some additional breaking news today. After inspections of 15 planes, 3 Boeing 737 NGs have been found with cracked pickle forks. The FAA to require inspection of planes with 22,600 flight cycles. Planes with 30,000 cycles need inspections within a week. A big issue for busy airlines. So what's a pickle fork? Let's talk about the structure of the 737. I'll be using some 737 MAX photographs, as that's the only information I can find online as to the detailed structure that we're talking about. But nevertheless, the basic pickle fork structure remains the same for the 737 NG series. The MAX simply doesn't have enough time on the airframes yet for this to become a problem for the MAX series of aircraft. It may not become a problem at all. There may be substantial design changes we don't know about. We're going to start by removing a couple of inspection panels here on the Mighty Luscombe and showing you a quick review of basic aircraft structures that are similar to the Mighty Luscombe here, built in 1946, that pertain also to the 737 series of aircraft. As an airframe and power plant mechanic, that's the first thing I did after high school and was one of the best things I did for my career, to go get that rating. 2-year long program right after high school. I'm able to work on my own aircraft. I'm not able to sign off its annual inspection. Each year on light aircraft, you got to open up all these inspection panels and do a thorough annual inspection on the aircraft to return that aircraft or to maintain its airworthiness certificate. So I can do the work, but I just cannot sign off the annual inspection. I have to get an AI, an authorized inspector, to do that work.
We're going to switch over to the GoPro now for its wide angle capability and low light capability as well. The structure of the wing of the Mighty Luscombe is very similar to other major wing structures, including the 737, and consists of some similar basic concepts. Each wing has a main spar that it carries the main part of the flying load, and the wing has a rear spar to handle any twisting motion. Both spars run the length of the wing all the way out to the tip and are attached here at the fuselage in what is called the center section. This whole structure area in the Mighty Luscombe is the center section. Specifically in the case of the, let me close that door. Is that door too? Yeah, let me do that. This center section of the main spar in the Luscombe represents the strongest part of the aircraft. It ties in the main spar of the wing with the fuselage to the wing struts and the landing gear. It transfers the load of the main spar through these attach bolts, through this hat section, and across to the other wing. This section transfers the load to the fuselage and connects down here to the main wing strut and the landing gear. And this wing strut, of course, attaches the main spar and the rear spar. This is also where you can control the twist of the wing, or adjust the twist of the wing for wash in and wash out. This main spar attach point also connects to the engine mount. And by the way, if you're in the market for an old Luscombe, you got to look for corrosion. These are all metal, all aluminum aircraft, and these center hat sections they're called, it's just a simple hat section of aluminum that transfers this load, has an airworthiness directive out on them to inspect these sections for corrosion. In this Luscombe, these sections of aluminum were completely replaced when the aircraft was restored some 12 years ago. The spar inside the mighty Luscombe wing is an extruded aluminum I-beam structure that's tapered at the tip. This is a metal wing illustrated here. Luscombes came in both metal wing and fabric wings like mine. This created a very strong structure as illustrated in this early advertising literature. And in the event of a crash, this strong center section makes the Luscombe a very survivable aircraft. Now let's go look at the 737 design and these pickle fork attach fittings. Since its inception in 1967, the Boeing 737 series of aircraft has been the most successful airliner in airline history. Over 8,500 737 sold worldwide. The launch customer for the 737 was not located here in the United States, it was Lufthansa in Germany. Like the James Brown of aviation, it's the hardest working airliner in the airline industry. With over 1,200 airplanes in the air at any given time in the world and one landing less than every 2 seconds, these aircraft get a lot of wear and tear, especially with the short hauls that they fly. Coupled with the fact that there are so many variant models of the 737 has a long list of airworthiness directives. And the cracking in this pickle fork design may soon become an AD itself. More on that in a moment. First, let's look at how the new 737 MAX is assembled in Renton. The fuselages come 2,000 miles away from Kansas City without a wing center section. By the way, I have to use the MAX example here because I have no good pictures of the NG series of aircraft being assembled. The concepts are the same. Once the fuselage gets to Boeing Renton, all the interior components are added to the fuselage, including a wing center section. The wings themselves are built in Renton, and the fuselage is lowered on the floor, and the wings are attached. By the way, this whole assembly process takes about 9 days once the fuselage gets to the factory at Renton to push the completed airplane out the door. Now let's take a closer look at the critical wing center section. This is the strongest part of the aircraft that's responsible for transferring the forces from the wings to the fuselage and vice versa. Here's the center section on the 7.3 design, and not only does it hold the wings to the fuselage, it also creates a huge fuel tank, the center fuel tank. By the way, the nose of the aircraft is off to the right. There are 4 pickle fork assemblies that attach the center section to the fuselage, and one of these assemblies, you can see the fork itself right here. I suspect that there's one pickle fork assembly for each corner of the center section, but I've not been able to determine that in my studies so far. The pickle fork is a continuous assembly that goes up above the windows, wrapping around about 1/4 of the circumference of the fuselage. And here's what the pickle fork looks like from a structural analysis rendering. Using my own crummy Blanco Lirio graphics here on the whiteboard with the aircraft oriented forward this direction, here's your wing center section, forward spar, rear spar, and the fuselage. And here the pickle forks attach
the center section to the fuselage, transferring all of those forces. A side note, as an operator, the fuel located in the wings are considered or called the main fuel tanks, and the center fuel tank located in the center of the aircraft is to be burned first. Burn that fuel out of the center of the aircraft to avoid excessive bending moments on the wings. That's your standard fuel management plan on all of these airliners. So this issue was discovered on an aircraft they were converting for freight operation in China. This aircraft had somewhere around 22,000 cycles. A cycle is each landing and takeoff, each inflation of the balloon, of the fuselage, if you will. These pickle forks are supposed to be designed to last the lifetime of the aircraft, which is considered about 90,000 cycles. So less than a third of the lifespan of the aircraft based on the number of cycles. These pickle forks are beginning to show cracks, and they found cracks in 3 aircraft out of 15.
Again, this only pertains to the 737 NG series of aircraft, those aircraft with a high number of cycles on them. This has nothing to do with the MAX at this point.
Here in the States, there's 3 airlines that are operating NGs with at least this much time on them, and that's Alaska, Delta, and Southwest Airlines. So basically, the system worked. Operators or engineers out in the field discovered cracks in the pickle forks that they were working on at Boeing, and they immediately went up the chain of command with their concerns, and that information got right straight away to the FAA, and now today the FAA is acting on it. So we'll keep you posted on how this plays out. This should become an airworthiness directive very soon, and when we get the detailed information on that, we'll certainly let you know, and the airworthiness directive will give the guidance required to get these pieces inspected properly to maintain the airworthiness of the aircraft. And this inspection could be pretty straightforward. It could be a visual inspection, and there's various forms of non-destructive testing they can do to determine the airworthiness of these parts, including eddy current inspections and fluorescent dye penetrant. So I hope this gives you a better view of what's going on with the pickle on the 737 NG series of aircraft. Thanks again for watching here on Patreon. We'll look for a lot of big changes hopefully soon on this channel. Stay tuned. See you here. Took me all day to do this, see? I'm wiped out. See you here.